We're going to be reviewing for test 3.2, the test we're taking tomorrow. We're going to do all of these problems together right now. So number 1 says, a new spiral notebook contains 30 more sheets of paper than a new memo book. The total number of sheets of paper in 3 new spiral notebooks and 5 new memo notebooks is 810. So we're going to write a system of equations that can be used to find S, the number of sheets of paper in 1 new spiral notebook, and M, the number of sheets of paper in 1 new memo book. All right, so a spiral notebook, we start with here, a spiral notebook, I'm going to highlight, contains 30 more sheets of paper than a new memo book. So what variable stood for the spiral notebook? S. So I can say S equals 30 more would be 30 plus the number of sheets of paper in a memo book, right? So S equals 30 plus M. All right. Then it says 3 new spirals and 5 new memo books contain 810 pages. So if I say 3 times S, that's the total number of pages in 3 spirals, right? And 5 times M is the total number of pages in 5 memos, is 810. That's the system. That's it. Number 2 says, the sophomore class needs a combined total of 216 medium and large t-shirts for field day. The number of medium t-shirts needed is 3 times the number of large t-shirts needed. So based on this information, find the number of medium t-shirts needed. So let's start with the first sentence. Says we have a combined total of 216 medium and large t-shirts. So the first thing I need to do is decide on my 2, because I have 2 unknowns, right? The number of medium t-shirts and the number of large t-shirts. So what variable could I use for the number of medium t-shirts? M? Okay. Oh, wrong type of pen. There we go. So I'm going to say M equals the number of medium shirts. And what should I use for large? L, sure. So L equals the number of large shirts. So far, so good? All right, so that first sentence says, if I combine these 2 together, how many total shirts do I need? 216. So I could say M plus L equals 216. All right. Then I've got the second sentence here says the number of medium shirts needed is 3 times the number of large shirts needed. So M equals 3 times L. All right, and then finally they ask us to find the number of medium t-shirts that we need. So how can I solve this? Am I going to use substitution, elimination, or by graphing? I would use substitution because look, we've got an equation that's already has a variable isolated, right? Perfect. So I would use substitution. So I'm going to substitute, see here, this 3L in for this M. So let's write that out. So I'm going to have 3L plus L equals 216.
So 4L.
Perfect. So I have 4L equals 216. So then I divide by 4. So how many large shirts do I need? 54 large shirts. But the question asks for how many medium shirts do we need? So how am I going to find medium shirts? Multiply by 3. So my medium shirts, see here, I'm going to scoot over a bit. So my medium shirts equals 3 times 54. So how many medium shirts?
162.
162?
Yes.
There we go. So I need 162 medium shirts. Beautifully done.
Where did that answer play off?
Yeah, I moved it off to the side.
No, but where did it play off?
To Never Never Land. Number 3 says, what is the solution to this system of equations? So I've got two equations, one system of 2 equations, and they're both in standard form. So what method could I use to solve this system? Do I want to use substitution, elimination, or graphing? I agree, I would use elimination. So what do y'all want to eliminate, the x's or the y's? Ooh, y's because one's positive, one's negative, right? But what do I need to multiply that second equation by? By 3. So if I multiply the second equation by 3 first, so I'm going to keep the first equation. I have 6x plus 3y equals 13. And I'm going to multiply the second equation. So 3 times 3x is 9x. 3 times negative y is minus 3y equals 3 times 4 is 12. So I'm going to add these two equations together. So I get 15x. My y's are eliminated. Equals, what's 13 plus 12? 25. So then if I divide both sides by 15, I get x is equal to, what is that, 5/3?
Yes.
All right, so then we got to solve for y. So then I'm going to use, which equation should I plug 5/3 into, the first or the second? Whichever one y'all want. First or second? First? Second? First?
Second.
First.
Second.
All right, so I like the second because there's no coefficient in front of y, but why do y'all like the first?
Just because
It's all positive numbers?
Yeah.
All right. All right. I'm going to go ahead and do the second because there's fewer numbers. I agree with Isaiah. But it doesn't matter which one we use? No, not at all. So if I say 3 times 5/3 minus y equals 4. So what is 3 times 5/3? 5. So I have 5 minus y equals 4.
And we already know what y is.
So if I subtract 5 from both sides, I get, I'm running out of room, so I'm going to write right over here. Sorry. Negative y equals negative 1. So if I divide both sides by negative 1, I get y equals 1. So my answer, I got a little space right here in the middle. My answer is going to be 5/3 1. All right. Number 4. So number 4 says, which graph can be used to find the solution to the system of equations below? So they're wanting to solve this system by graphing, right? So how am I going to do this? What could I do? What are my options here? I could graph them. How? Oh, I could use the calculator, right? Y'all want to do that? Y'all want to use the calculator?
Sure.
All right. So, all right, so you won't be able to see the graphing portion in the calculator, but I'll walk through all the steps. So in the video, you won't be able to see this part, but you guys in class right now can see this part. So I'm going to add a new graphs page. And how do I graph in standard form? What do I need to do? Not a solution, a relation, right? So I'm going to try to graph a relation. And so the first one is x. Oh, good question. Menu, graphs, sorry. So I'm going to push backspace to delete the equal sign, and we're going to go all the way down to relation. So I have x plus y equals -3. Well, right there,
It's x minus y.
oh, did I put plus? Oops. There we go. That would explain it. I was like, wait a minute. Minus y. So right there. All right, okay. So then let's go ahead and graph the second one. The second one, I've got 2x. You can already tell, but I just want to make sure. Plus 3y equals 4. So right there, where do those two lines intersect? -1, +2. So if I go back here to my graphs, which graph does that match?
Middle.
The second one, the middle one. Almost there, right? Because I was looking to see, well, where do those two intersect? Yes, sir.
How do you put this on a graph?
On the calculator?
No.
Let's take a look at problem number 5. Problem number 5 says, a bag contains 30 coins consisting of dimes and nickels. Right? Real life problems right here. The total value of the coins is $5.25. I want to write a system of equations that can be used to determine the number of dimes, D, and the number of nickels, N, in the bag. So I'm going to look at my problem here. The first thing it says is there are 30 total coins, right? So if I add up D, the number of dimes, plus N, the number of nickels, that gives me a total of 30. My second clue says the total value of the coins is $5.25. $5.25. So, how can I find out the total amount of money I have in dimes if I know how many dimes I have? You can. So if I have 1 dime, how much money do I have? 10 cents. So that's 0.1 of a dollar, right? If I have 2 dimes, how much money do I have? 20 cents, right? 3 dimes, I have 30 cents. So what am I doing to the number of dimes? I'm multiplying it by what? 10 cents, right? 0.1, right? So here I'm going to say 0.10 times D tells me how much money I have in dimes, right? Plus, how am I going to find out how much money I have in nickels? 0.5? 0.05, because a nickel is, right? 0.5 would be a 50-cent piece, right? So 0.05 times nickels equals how much total money did we say we had? $5.25. There we go. That's our system. Number 6. Number 6 says, gentlemen, ladies, y'all ready? Number 6 says, what is the value of x in the solution to this system of equations? Well, there's a couple of different ways I could solve this, right? Well, both equations are set up in standard form. So what method should I use? Substitution, elimination, or graphing? Elimination? Ooh, I like that because what does the question ask for? Does it ask for both?
It just asks for x.
It just asks for the x. So what could I eliminate so that I solve just for the x?
Y.
If I eliminate the y values, I get just the x, right? Hey, let's try that. So I've got 12 and I've got 9. What's the least common multiple of 12 and 9? 36. So what could I multiply to 12 to get 36? 3. And what could I multiply to 9 to get 36? 4. Isaiah, you got this one? All right. So 3 times 15x is 45x minus 36y equals 3 times 13 is 39. And then 4 times 30x is 120x. 4 times 9y is 36y equals, and 4 times 4 is 16. So if I add these two together, I get 165x. My y's are eliminated. Equals 39 plus 16 is what? 55, I believe. Right? So now to get x by itself, if I divide both sides by 165, you get 1/3. So the x value is 1/3. All right. Number 7. Number 7 says Janie has 196 rock and country CDs that she listens to at home. If there are 76 more rock CDs than country CDs, how many of each does she own? So first I have to write a what? An equation, a system of equations, right? So, what two variables should I use for rock and country CDs? R and C? All right, so I'm going to write that. I'm going to say R is going to be the number of rock CDs. C is going to be the number of country CDs. So how many total CDs does Janie have? 196. So I can write the first equation, R plus C equals 196. Here it says she has 76 more rock than country CDs. All right, so to write that equation, I'm going to start out with R equals or C equals? R equals, because the number of rock CDs is 76 more than the country. So to solve this system, are we going to use substitution, elimination, or graphing? Substitution, exactly, I agree. Because R is 76 plus C, so I'm going to replace the R with 76 plus C. So I have 76 plus C equals 196. I have to scoot over a bit. So then that's 76 plus 2C equals 196. So if I subtract 76 from both sides, so that gives me 2C is equal to 120, right? Wait, where did I get the 2 from? Because I have 1C plus 1C will give me 2C. I was combining like terms. Good question. All right, so then I'm going to divide both sides by 2. So how many country CDs does Janie have? 60. Perfect. So now to solve for how many rock CDs she has, what am I going to do with that 60? Add 76 to it. So R equals 76 plus 60. So how many rock CDs does she have?
136.
So she has 136 rock CDs and 60 country CDs.
I love country music.
Awesome. That's enough of that, you guys. Number 8. Number 8 says a college student needs 11 classes that are worth a total of 40 credits in order to complete her degree. A college offers both 4-credit classes and 3-credit classes. So we're going to write a system of equations that can be used to determine F, the number of 3-credit classes that a student can take to complete her degree, and H, the number of 3-credit classes. So, first I read, what's the total number of classes she needs? 11. So I could say F, that's the number of 4-credit classes, plus H, that's the number of 3-credit classes, equals what? Well, that's 40 credits. We're talking about what right now? The number of classes, right? That equals 11. All right. Then if I say 4 times F, that will tell me the total number of credits she got from the 4-hour classes. Plus 3 times H is the total number of credits she got from the 3-hour classes, equals what? 40.
But still, if we want over 4 credits, she's still technically getting all her credits.
Yes. And that depends on the university and their degree plan rules. Because some universities, you can only take so many credits. It depends on your major and the school you're going to, and if you have credits coming in from other universities. That's when you need to go talk to an advisor. All right, number 9. Number 9 says, what is the solution to the system of equations below? So I have y equals 3x minus 3, and 3y equals 9x minus 9. So how could I solve this? By substitution, elimination, or graphing? I agree, I would do substitution. So, because why? Perfect. So I'm going to have 3 parentheses 3x minus 3 equals 9x minus 9, right? So what's 3 times 3? Sorry, 3x. 9x, and 3 times negative 3? Negative 9 equals 9x minus 9. All right. So if I subtract 9x from both sides, I'm going to have to write it over here. I'm sorry, I ran out of room. I get negative 9 is equal to, oh wait, that cancels there too, right? Negative 9. So if those are equal, do I have just one solution? No. How many solutions do I have? Infinitely many. I did. So that means that those 2 lines, when I graph them, are going to look like what? Like one line. They would look like the same line. So that brings me to my next question. My next question says, if I graph a system of linear equations, how do I know that there's no solution?
The lines don't touch if they're parallel.
If the lines don't touch if they're parallel, they'll never have an intersection. They'll never have a solution. I'm going to say if the lines are parallel, that means they have the same slope, right? Then there is no solution. All right. Last problem. Last problem says you have a jar of pennies and quarters. You want to choose 15 coins that are worth exactly $4.35. So I'm going to write and solve a system for this situation. So first, what are the two, no, I was going to say, sorry. What are the 2 variables I can use for pennies and quarters? P and Q? I love it. So P is going to be the number of pennies. Q is going to be the numbers of quarters. All right. So what's my first equation? It says, what's the total number of coins I have? 15. So my first equation, I'm going to say P plus Q equals what? 15. All right, so if my total is $4.35, well, what can I multiply to P to find out how much money I have in pennies? 0.01. 0.01 P plus 0.25 Q equals $4.35. All right. So then we need to solve this system. How do y'all want to solve this? Substitution, elimination, or by graphing? your choice. I'll solve it however y'all want.
We should do a graph.
You want to do a graph?
Yeah.
Sure. All right, so are we going to solve it by graphing in our calculator?
Yeah.
All right, so if I do that, I need to change P and Q to what? X and Y. So let's make the P's, the pennies are my X's. Let's make the Q's my quarters. So again, if you're watching this video online, you're not going to be able to see my calculator screen, but you guys here can. So, see, I'm just going to add a page and start over. So add a graphs page. So I want to graph a what? A relation. So number 6. So I'm going to type in X plus Y equals 15 and 0.01x plus 0.25y equals $4.35. Oh, so I need to zoom out, don't I? So what should I change that y value to?
100.
60? Oh, 60 works. So then to find that intersection, I've got menu, analyze, intersection, right? So what's my solution here? Where do those two lines cross?
Negative 2.5 and 17.5.
And 17.5, right? So is this reasonable? Is this reasonable? Can I have negative 2.5 pennies?
Oh, no.
No. Can I have 17.5 quarters? No. Why not?
Because you can't break them in pieces.
We can't have fractions of a penny or fractions of a quarter, right? And we can't have we don't want to owe 2 pennies. That's crazy. All right. So that's what I want you to tell me for part B. You can't have fractions of a coin. And we can't have negative coins. We don't want to owe money. That's silly if you've got a jar of quarters and pennies.